This is lesson 4 of unit 10. In this lesson we'll talk about something called percent yield. Now this will relate to stoichiometry, what we've developed in the first 3 episodes, and we'll use stoichiometric calculations to determine percent yield. So let's get to it. Let's go ahead and define our terms. Theoretical yield and actual yield. Theoretical yield is the amount of product that should be formed based on stoichiometry, whereas actual yield is the amount of product produced from experiment. And this is usually less than the theoretical yield. So the idea is, when you perform a chemical reaction, you form a bunch of products. Now those products are not always perfect in terms of you don't always produce how much you predicted. Think of the idea back to the s'mores, and say for example that you have a whole pack of graham crackers, and you can theoretically say, well, from this pack of graham crackers, and you count, and we'll say there are 40 graham crackers in the pack. You say, well, we should be able to produce 20 s'mores, correct? And you set out to make 20 s'mores. However, in the process, you find some broken graham crackers, you find some incomplete graham crackers, some have been crushed, and in the end you only end up making, we'll say, 17 s'mores. So the 17 s'mores would be your actual yield, whereas the 20 s'mores would be your theoretical yield. And then what we can do is we can calculate the percent yield, the percent of s'mores that we made based on what we should have, is the idea. And we define percent yield in this way. Percent yield is the actual yield on top divided by the theoretical yield times 100 because of the percent. So what we're calculating here is how much did we actually make based on how much we predicted that we would make. This is a very common way of doing stoichiometry, because reactions don't always produce the perfect amount of products. So really what we have to do is do this calculation and see if we can calculate the percent yield. So the calculation asks us, when 65 grams of NH3 reacts with excess O2, 88 grams of water is made. Calculate the percent yield. So what we're saying is we're reacting 65 grams of NH3 and making 88 grams of H2O. Now the 88 grams is the actual yield. So this number right here, this is our actual yield. This is how much we actually made when we went to perform the experiment. This is not how much you would predict you would make. So let's first calculate our theoretical yield. This would be our theoretical yield. And the theoretical yield we'll have to convert from grams of NH3 to grams of H2O. So this is a grams to grams conversion, which means we have episode 3. It'll require 3 steps. So let's go to it. We have 65 grams of NH3. Remember, a 3-step conversion problem involves going first from grams of NH3 to moles of NH3. Then we go from moles of NH3 to moles of our desired product, which is H2O in this case. And then finally we go from moles of H2O to grams of H2O. When we fill this in, a mole is simply the mass from the periodic table. In our case, NH3 should be 1703. Moles to moles conversion comes from the balanced equation. We have a 4 to 6 ratio. So 4 moles of NH3 produce 6 moles of water. And then finally, for moles of water, 1 mole is 18.02 grams of water. Okay, let's go ahead and do this calculation. Go ahead and do it with me in a calculator. Make sure I do it right. 65 times 1 divided by 1703 times 6 divided by 4 times 1802. We get ourselves 103 grams of H2O. So notice this is bigger than 88 grams. 88 grams is our actual yield, and the actual yield should always be less than the theoretical. Theoretical is how much you predict from stoichiometry. That's the perfect amount. Okay, so Let's go ahead and calculate our percent yield. And percent yield is our actual, which is 88 grams, divided by our theoretical, which is 65. I'm sorry, which is 103 grams, not 65. Came from 65. 103 grams. Don't forget to multiply by 100. And do this calculation with me. 88 over 103 times 100 should give you 85% yield. And this is the final answer. So we essentially produced 85% of the product that we should have. And the reason why this is the case, because chemical reactions are a little more complex. Maybe the conditions weren't perfect. Maybe we didn't react. Sometimes the reaction doesn't go to completion. There are many factors, but 85%. So incidentally, usually you go from grams to grams. You could be asked to go from moles to moles. So you can use really any episode 1, episode 2, or episode 3 for these types of problems. Most likely, though, for theoretical yield, you'll use episode 3. Okay, so take a moment to stop and think about what we did, and go ahead and try an example problem of your own. Try to get the percent yield for this problem. And that wraps up for us lesson 4 of Unit 10.